Hello everybody, so this is Mr. Bowman. Today we're going to be looking at parallel lines from the geometric perspective, as well as some vocab that ties into the angles and the lines themselves and stuff that's tied in there. So first things first, if you want to say two lines are parallel and maybe those lines are named M and L, you use two parallel lines in between them. So this is saying M is parallel to L, and that is perfectly equivalent to saying L is parallel to M. So the order doesn't matter when you're listing out your lines. Okay. Now, if you have lines already, to know they're parallel, they're going to use a notation of replicating some of these arrowheads there. And they're going to be somewhere in the middle of the line. So these are saying these two lines are parallel. And you do want to make sure they have the same amount. In case you have more sets of parallel lines, they're going to differentiate by adding more here. So these are saying these are both parallel because they both have 3 sets of those extra arrowheads. If they're different, if say the top one has 3 and the bottom one has 4, those are not parallel. Okay, so they have to have the same amount for those to be parallel. So if you see that, usually you don't get too many of them. I think the highest I've ever seen is 3 in a single problem, but you'll see lots of 1s, lots of 2s, like double arrowheads with 2 there, sometimes 3, but usually it doesn't get too crazy. All right, so if you have your parallel lines, so these are parallel, put my little arrowheads on there, then you have a line that cuts across them. That line that cuts across them is called the transversal. Okay, so that's a transversal. And it's important because that when you have parallel lines cut by a transversal, that gives you 8 different angles, 4 around this top one and 4 around this bottom one. So let's go ahead and call it angle 1, 2, 3, 4, 5, and 6, 7, and 8. I missed 2, but that's okay. So 1, 2, 3, 4, 5, 6, 7, 8. The ordering doesn't really matter. Okay, so now that we have that, we can differentiate which one's which. So there are 2 kind of characteristics we're looking for right now. So I'm going to draw a little Punnett square style diagram here. So in terms of our transversal, we're going to have either alternate, which means they're on opposite sides. So one angle will be on the right, one will be on the left, or vice versa. Or same side, so they're both on the left, both on the right, something like that. Okay. So these are in terms of the transversal. And then in terms of the parallel lines, we'll have interior or exterior. Okay. So this is going to be our first way we can break down these lines. All right. So in this case, so how to read this is this box will be alternate interior angles. This one will be same side interior angles. This will be alternate exterior or same side exterior angles. Okay, so you're going to need both of those words to describe our sets of angles. So alternate interior angles, before we do that, one other thing important to note here is for this entire diagram here, we need one angle from our top and one angle from our bottom to make our pairs. Okay. So I'm looking for sets of alternate interior angles. So alternate means one angle has to be on the left and one has to be on the right of our transversal. And interior means we're inside our parallel line. So it'll be these 4 angles between the 2. So for alternate interior, I could have 3 and 8. So 3 is on the left, 8's on the right. And they're both inside the 2 sets of lines. So 3, 4, 7, 8 are interior angles. And then our other option is 4 and 7. Okay, I can't use, for example, 3 and 4 because 3 and 4 are both on the same angle. I need one from each. Okay. All right, moving right along then. Our same side interior angles It means they either have to both be on the left or both be on the right, but they're still interior, so that would be 3 and 7, and 4 and 8. So 3 and 7 are both on the left, 4 and 8 are both on the right. For our exterior angles, we're going to do basically the same idea, but instead of using 3, 4, 7, 8, our interior angles, I'm going to use 1, 2, 5, and 6, which are our exterior angles. They're past the parallel line, so above it and below. So our alternate exterior angles would be 1 and 6, because 1's on the left of our transversal and 6 is on the right. And then similarly, 2 and 5. And then same side exterior would be 2 and 6 and 1 and 5. So 2 and 6 are both on the right, 1 and 5 are both on the left. Okay. All right, so that is one way we can break those down, and that's probably a, I don't know if I'd say more common, but a very common one. There's two other types that we can use as well. Actually, let me move just a little bit further up. So I'm going to keep using the same picture, and that's looking at things called corresponding angles and vertical angles. Okay, so corresponding angles are angles that are in the same location on the top intersection and the bottom intersection. So they either both be on the upper left or the upper right or bottom left, bottom right, whatever. But important to note here, for each of these, notice there are two pairs for alternate interior, alternate exterior, etc. You're going to have 4 pairs for each of these sets. So when I'm looking at corresponding angles, I could have 1, which is, if we look at our intersection, is in the upper left, so I go up and to the left. I can do that same pattern from this intersection, which lands me at 7. So 1 and 7 would work. Then if I go up and to the right, that'll take me to 2, so 2 and 8, 3 and 5, and 4 and 6 are our corresponding angles. Okay. Our vertical angles are different than our others in the fact that they are around the same intersection. We don't have one from the top and one from the bottom anymore. Okay? So for vertical angles, it's going to be opposite angles that are at the same intersection. So for example, 1 and 4 are opposite of each other, but they're both in the upper intersection. Similar, 2 and 3 are opposite each other. Then if I keep that pattern down here, I have 7 and 6 and 5 and 8. Okay, opposite, opposite. Okay, now we're going to learn more about why we want to know those sorts of things over the course of the next couple days. But before we do that, we have one last thing to wrap up quickly here. And that's looking at relationships of those intersections. So if I take this one, if I pick any angle, okay, I'm going to pick one that's nice and easy to calculate. So I'm going to go with 30 degrees. And I say this is 30 degrees. I can use things I already know and fill in almost this entire thing. And with one small new piece of information, I can fill out all 8 angles with just that one angle. Okay. So let's look at what we know first. This is 30 degrees, and this is a straight line. And if it's coming from a straight line, then that means that those angles have to be supplementary, which means they add up to 180. So if this is 30, I can just do 180 minus 30 and find out that this is 150. Okay? And I can do the same thing here because this is also a straight line. Okay? And if that's the case, then I can use either one of those, for example, this bottom one, to say, well, this is 150, that's a straight line, so this has to be 30. Okay. We're going to see a lot of repeating numbers in this pattern. So I have half of them done. So the only new piece we need here is to know that any corresponding angles have to be equal or congruent. So if this one is 30 degrees, and that's my up and to the right, then up and to the right here has to also be 30. And this one is down and to the left, then down and to the left has to also be 30. If I continue that pattern, down and to the right has to match, up and to the left has to match. There are only two options. So if I have any single number, I can fill out this entire chart pretty quickly. And we're going to see in the next video an example of why we might want to do that.